Hello, my name is Thiago and I will be presenting the article with title Performance Analysis and the Application of Mobile Blockchain in Mobile Edge Computing Architecture. This work was done in conjunction with two other researchers, Admilson Lima and Moreno, both from the Computing Department of the Federal University of Sergipe, located in Sergipe, Brazil. The summary of this presentation is composed of the sections of the mentioned article: summary, introduction, concepts, related works, performance evaluation methodology, results, and conclusion. The abstract. In this paper, blockchain benchmark studies carry out mobile devices, illustrating its process with help of architecture that allows the best blockchain performance of mobile devices using edge computing. With this benchmark, with regard to the performance achieved, it is possible to compare the difference between use of blockchain in a mobile edge computing architecture and without that architecture. So we validate that edge computing to the mobile blockchain mining process increases its efficiency. About blockchain, a short introduction. Blockchain is a system that allows the direct process of the and receiving of some types of information over the internet. They are pieces of code generated online that carry information like blocks of data that form a chain. As the technology blockchain continues to evolve, it has an increasing opportunity to help applications for mobile device, increasing the security aspect of the security characteristics of these networks. This is interesting for mobile security, as it has become increasingly important due to the growth in the use of mobile applications for financial transactions. Any concepts uh, about information security? According to Lira, information security is characterized by the proper application of protection device on an asset or a set of assets in order to preserve the value that it has for organizations. The application of these protections seeks to preserve confidentiality, integrity, and availability, not only being restricted to systems or applications, but also information stored or transmitted in different media besides electronic or paper. Again, blockchain. Blockchain, also known as the protocol of trust, is a distributed ledger technology that aims at decentralization as a security measure. They are distributed and shared database of records and data that have the function of creating a global index for all transactions that occur in a given market. It works like a ledger, only in a public, shared, and universal way, which creates consensus and trust in direct communication between two parties, that is, without the intermediary of third parties. Concept of difficult, the cryptocurrency difficult is a measure of how difficult it is to mine a block in a blockchain for a particular cryptocurrency. A high cryptocurrency difficulty means it takes additional computing power to verify transactions entered on a blockchain. The higher the difficulty needed to create a block improves a cryptocurrency network security since attackers would need enormous resources to take control. The proof of work concept is a form of adding new blocks of transactions to a cryptocurrency blockchain. The work in this case is generating a hash, a long string of characters, that match the target hash for the current block. About the mobile blockchain, blockchain can be used to develop applications with mobile device. However, to support the blockchain-based service, there is a set of miners continuously running a consensus protocol to confirm and secure data or distributed transactions in the background. And digital miners are required to solve Q puzzle. The mining process is conducted in a torment structure, and miners chase each other for the solution. In the graph, in the image, the first step in a case of mobile blockchain, node A on a mobile device sends data to node B. Node A device perform a transaction. The transaction is transmitted to P2P network promising the other computers called network nodes. And the nodes of the P2P network broadcast the transaction and create a new block. The participants verify the block and validate, and the consensus protocol confirms valid block. The block confirmed, the valid block is sent to the participants to be permanently saved in the current blockchain. And each blockchain node contains a complete blockchain. Finally, the node B can access the transaction using its private key. The last one, mobile device can access edit servers to enhance the computing power. With this feature, edit computing becomes a promising solution for mobile blockchain applications, whose benefits are as follows. First, by incorporating more miners, the robustness of the blockchain network is naturally improved. Second, mobile users have an incentive from the rewards obtained in the consensus process. About related works, the related works mostly emphasize the need to use mobile edit computing architecture to support mobile blockchain. Among the works that address the subject is that by Xuelian Liu, the efficient auction mechanism for adding computing resource allocation in mobile blockchain. The figure demonstrates in the last item the mobile adding computing architecture. About the performance evaluation methodology used in this work, the benchmark, some devices, some architectures, and some metrics were defined. The physical device Xiaomi Redmi 7, the workstation notebook Alvel A62 EMUV, and the virtual device Pixel 3a and the iPhone 12 were used with the CPU and RAM specifications shown in this presentation. two architectures were used in the mobile blockchain benchmark. One without the use of adding computing in the blockchain network validation process, and another with the use of adding computing to support the mobile blockchain. Regarding the metrics used in benchmark, the following were chosen: CPU and memory consumption, physical device battery consumption, number of transactions on the blockchain network, difficult, they measures how difficult it is to extract a block of information on the blockchain network, and the processing time. In, in the image, we have the architecture of the mobile blockchain without the use of any computer. Only the physical and emulated device. In the right side, we have the mobile and the computing architecture with the use of Heroku and Back4App and Firebase service serving as adding nodes for the blockchain network process. In left side, we have the first architecture. In right side, in the use of Heroku, Back4App, and Firebase service. In this image, we see the comparison between the architectures involving benchmark. The highest point of the sorry, in this image, we see the comparison between the architectures involving this benchmark. The highest point of the graph is reassured by the experiments performed without the use of adding computing. The lowest point experiments performed using adding computing. The graphic is tiny in seconds per number of transactions on difficult 4. In this graph, we have the CPU consumption of the Xiaomi Redmi 7 physical device for difficult 4. The green line indicates when the adding node is used. The blue line indicates when adding computing is not used in the mobile blockchain. The increase in CPU consumption is shown. Something similar happens with memory consumption. In the percentage consumption by number of transactions graph, RAM consumption is highest without using adding nodes and lowest when using adding computing. Finally, the battery consumption of the Xiaomi Redmi 7 physical device was measured while processing the mobile blockchain with difficult 4. In the graph, the black line indicates the drop in battery level over time. Just below the black line, the blue lines indicate the exact times when a battery level drops. This is the scenario that does not use adding computing in blockchain network processing on mobile device. With the use of adding nodes, there is no battery level drop because of the process of the blockchain network is transferred to the edge servers that process it and return the result to the physical device, removing the responsibility of doing this. About the conclusions, uh, the conclusion drawn from this benchmark is great. The difficulty of the blockchain network more efficient, the use of edge computing to assist in the mining process. This is more evident in our experiments since it is possible to notice the considerable difference in mining time when using the edge computing architecture compared to not using it. Thanks. Any questions? My mail in screen.
Thank you for your presentation.